So today we're going to start focusing on chapter 3, section 2, which is understanding polynomial functions of a higher degree. So what we're doing here is our x to the thirds, x to the fourths, x to the fifths. This is where we're going to start graphing these polynomials that are bigger or greater than like an x, to the first power, which is linear, or an x squared, which is a, quadratic or a parabola. So to graph these higher degree polynomials, we're going to look at the equation and we're going to try to identify some key parts of the original equation, okay? So first of all, we're going to focus on end behavior. And what that means is we're going to try to determine how is the graph going to end. So for example, if you have a linear function, right? This is just let's say x plus 2, y equals x plus 2. If you were to graph this, you would see that the y-intercept is 2, the slope is 1, and it would look something like this, okay? And if you notice, if I was to say, hey, on this line, what is the end behavior? What's happening with these ends here? You would say something like the left is going down and the right end is going up, something to that effect, right? If I was to graph a parabola, let's say something like this, okay, this would be maybe the graph of an x squared, right, a quadratic, okay? If I was to ask you here, what is the end behavior, what are the two ends doing, you would say both ends are going up. So if you notice in the linear, the ends are going in opposite direction. This side is going up, this side's going down. If we go to the quadratic, you notice that both ends go in the same direction. Sometimes they both go up, and sometimes they can both go down, okay? And so what I'm going to teach you now is how to identify what the ends are doing without actually having to graph anything, okay? So if you have an odd degree polynomial, that means that the leading term is an x to an odd power, like 1. Or maybe an x to the third plus a 2x plus 7 or something to that effect, but notice that that's odd. So this would be x to the 1, an x to the 3, an x to the 5, an x to the 7, and so on. Anytime that leading term has a degree or an exponent that is odd, what's going to happen with the ends is they're going to go in opposite directions. So by opposite directions, what I'm saying is that if one side goes down, if the left goes down, the right is going to go up. Or if the left goes up, the right is going to go down. So you might say, well, how do I know which side goes up and which side goes down? Well, again, if you have that odd degree polynomial, if the a value, the a, remember, is the coefficient in front of that x, okay? So like, 1x to the first power or something like that. If that a value is positive, then it's going to be left down, right up. If the a value is negative, you're going to have up at the left and down at the right. So again, this is some memorizing. So again, if it's odd, the ends go in opposite directions. And then if it's a positive number in front, left down, right up. If it's negative, left up, right down. Now, what happens if the degree is even, like in a quadratic? Well, as you can see there, what happens is you have the same behavior at the ends. So both ends either go up or down. They go in the same direction. So how do you know which direction? Well, again, the a value is going to tell you that. If a is positive, both ends go up. And if a is negative, both ends go down. Okay? So that's how we kind of can identify when I see an equation, I can immediately tell you how the ends are going to go. So let me give you some examples. Let's say I have x cubed plus 2x squared plus 7x plus 3. That's a lot, right? That's a big equation, and you might be a little confused on how you're going to graph it. But if you look at this leading term, you see that the degree is odd, okay? So that means the ends are going to go in different directions. And then you look at the a value, which is positive, which means my left is going to go down and my right is going to go up. So I don't know what the middle looks like, but to be honest, I know that at some point my graph is going to go down here and up here. What I don't know is what's going to happen in the middle, and we're going to talk about that as well. But this is just talking about the ends. So again, let me give you another example. Let's say we do y equals negative 2x to the fourth power plus 2x minus 7, or something like that. Again, the degree is even. So I know both ends will go in the same direction, okay? And then because a is negative 2, so it's negative, I know it's going to be both ends are going to go down, okay? So the more you do, the easier this will become. Again, we don't know what's going to happen in the middle of the graph, but we, where the values are going to be, but we do know the ends. So 2 more things that will affect the way our graph will look. Okay, we already know that the end behavior is determined by that leading term. The zeros, so in a graph, when you're solving these problems, you're going to have zeros that we've talked about. We call them roots, we call them solutions. And basically what that is you take your equation, let's say you take a basic quadratic equation, and you do y equals, whatever, x squared plus 2x plus 1. And I ask you for the zeros. Well, how you find the zeros is you set the equation equal to 0 and you solve. So in this one, it's a quadratic. I know that this can be factored. This is x plus 1 times x plus 1. So I set each one of these factors equal to 0. And I get x is negative 1. And I actually get that solution 2 times. So my zeros, my roots, my solutions, whatever you want to call it, okay, these are my x-intercepts. So these are my zeros, like that. And if I go to my graph, they're also my x-intercepts. Now, we list x-intercepts as ordered pairs, but I know my graph is going to go through negative 1, 0. So when I come to my graph here, I know that this is one value on that graph. That's my x-intercept, okay? Now, if you notice, that solution occurred 2 times. The amount of times that something occurs is called multiplicity. So in this problem, negative 1 has a multiplicity of 2 because it shows up 2 times. So I know that negative 1 not only is my x-intercept, but it is also going to have a multiplicity of 2, which you might say, what does that matter? Multiplicity of 2 doesn't matter in listing the solutions, but it does matter in graphing. And what happens is that when you graph, right, if you have a multiplicity that occurs an even number of times, like this one, it shows up 2 times, that's even. What's going to happen when I graph this equation, okay, this quadratic, I'm going to, like if I look at this, I see that both ends go in the same direction, my end behavior, and they both go up. I know that my ends are going to go from there and they're going to go up. And when something shows up an even number of times, as I approach that intercept, okay, my graph doesn't go through that point, but rather bounces off of it and stays on the same side of the x-axis. If it shows up an odd number of times, I go through that point, okay? And so we're going to do a lot of problems, but multiplicity, if an answer shows up an even number of times, your graph will bounce off of that point, okay? And if it shows up an odd number of times, you will go through the point, okay? So let's kind of do some examples, and then you'll see more and understand more what we're talking about. So let's sort of look at this and talk about this particular equation. It says find the end behavior, the zeros, and the multiplicity. So again, for the end behavior, we're going to be looking at this leading term. Okay, so we've got 1x cubed. So we have a is positive, and the degree is odd. So again, odd degree means opposite directions, and positive means it's going to go down on the left and up on the right. So however you want to describe that, you can do down left, up right, or you can write it down left, up right, okay? The bottom line is you have an idea of how your graph is going to end on both sides. Now the zeros, to find the zeros, we have to solve. So to find my zeros, I'm going to set the equation equal to 0, and I'm going to try to solve this. Now this is a 4-term polynomial, and we know that we try to solve these by grouping. Now it can't always be solved by grouping, but today all of these will be factorable or groupable. When we get to section 3.4, we'll learn what to do when they're not factorable or groupable, okay? So here I'm going to pull out the GCF. I'm going to pull out the GCF of the second group. And if these repeat, they become one of my factors, and then the GCFs become the other. And so now I'm ready to set each one of these factors equal to 0. So x equals -2. And this one here can be expanded to x plus 2 and x minus 2, and then I can set each one of those equal to 0. So x equals -2 and x equals 2. Okay, I could have also solved it from here, right? Because x squared minus 4 equals 0 is x squared equals 4. Remember how to do this? So x equals plus minus 2, which is exactly what we got here. Okay, so it's up to you how you want to do it. But bottom line is we got 3 solutions for this problem, right? We got, which makes sense because it's an x to the 3rd power. We got -2, -2, and 2. So this has a multiplicity of 2 because it occurred twice, okay? This has a multiplicity of 1. So how does this all translate to a graph? Let me kind of give you a rough idea. Here's my graph, right? My zeros, remember that my zeros are my real x-intercepts. And so I know that I'm going to go through at -2, and I'm going to go through at +2. So I know I'm going to cross at -2. I'm going to cross at +2, okay? My end behavior is going to be, again, remember, down on the left and up on the right. So I've got that. And then just, I'll tell you that we've got our one value here that's kind of obvious, and it's our y-intercept. In this format, our y-intercept is always this constant value that's here. So I know that my graph is going to cross at 0, -8. So let's say -8 is down here. I know my graph is going to cross down there, okay? So now I've got 3 points on my graph, and of course I don't have the specifics about the middle, but I can tell you that my graph, because -2 has a multiplicity of 2 and that's even, I'm going to bounce off of that. So what's going to happen is when I go up here to -2, I'm going to bounce off of it. I'm not going to go through it. Now my graph is going to go down. I don't know how far. At some point it's going to cross through the y-axis. It's going to approach 2. And because +2 has a multiplicity of 1, I know that it's going to go through that one. So it goes through and out and does the rest of the graph. And so while this middle is somewhat imprecise, I know at least how it's going to perform. I know that it's going to bounce off of the -2 and it's going to go through the +2. And so again, we're going to get better at being more specific along the middle, but at least this is somewhat a good idea of what this looks like. And that's what I would expect. So in this question, when I ask you for end behavior, I'm going to want something that describes it. When I ask you for the zeros, I'm going to want them in this form, x equals whatever. You don't have to write the -2 two times if you don't want to. And when I ask you for multiplicity, you're going to be telling me multiplicity of 2 and multiplicity of 1. So again, if I'm graphing, I'm going to do what we just did. I'm going to determine the end behavior, right? I'm going to find my zeros and my multiplicity. I'm going to find the y-intercept like I showed you. And plotting additional points, that's going to help me figure out how high or how low I'm going to go in between those zeros and intercept. So let's do one. So again, let's come over to here and let's start one thing at a time. We're going to start with our end behavior. Okay, again, I'm going to look at 1x to the 4th, and I know that the 4 means the same direction and the +1 means up. So here I know both ends are going to go up. Okay, I'm going to find my zeros. I'm going to start there. I'm going to set the equation equal to 0, x to the 4th minus 5x squared plus 4. And if you remember how to factor these with a 4th and a squared, if you remember what we did was we said, okay, we can kind of do that like a quadratic. What multiplies to 4 adds up to negative 5. That's minus 4 minus 1. So x squared minus 4 and x squared minus 1. At this point, we can keep factoring. This is x plus 2, x minus 2. And this one here is x plus 1, x minus 1. Okay, so my zeros are going to be x equals negative 2, positive 2, negative 1, and positive 1. So these are my zeros, okay, right here. Okay, so far I've got my end behavior and I have my zeros. If I was to translate these zeros onto a graph, what this means, this is negative 2, this is positive 1, positive 2. My graph is going to cross at 2, at negative 1, at 1, and at 2. Okay, so I have my zeros. Now my multiplicity. Well, in this case, every solution, each solution has a multiplicity of 1. So that means I'm going to go through each zero, okay, or each solution, or each intercept there. I'm going to go through each one because they each show up an odd number of times. Last but not least, my y-intercept. Now, guys, my y-intercept, again, is in this form. It's always the constant, and we write it as an ordered pair. So I'm going to go through the y-axis at 0, 4. So, again, I come here, and here's 0, 4. So now I'm ready to come up with a pretty interesting sketch or close sketch of what this is going to look like. Remember, my ends both go up, right? And I'm going to go through each point. So I'm going to go through negative 2, turn back up, go through negative 1. At some point, I'm going to hit the y-intercept. I'm going to turn at some point, go through 1, and I'm going to come back up and go through 2. And notice that I kind of end with my both ends up, and it works. Now, what they're talking about with regard to additional points is this middle here, okay? Yes, I know I go through all those points, but what I'm not really sure of is how low should this point be, or maybe this point. Like, I'm just guessing that it only goes down to those numbers, but it could go down super low. So what I would really need to do, if I was really going to do this problem correctly, is I would need to pick a value in between these points. Like, maybe I would need to pick negative a half. Okay, now that's hard because it's a fraction, but I would need to pick negative a half, plug it into the equation, okay, and figure out what y is, because that would give me an idea of how low my graph is going to go. Sadly, I try to choose integers, but there's none available. So I would have to choose maybe negative a half, maybe positive a half. Maybe those would be the two numbers that I would pick. And so I'm not going to take all the time here to do that, but let's just say I did 1. I'm going to do positive a half, okay? So it would be a half to the 4th power minus 5 times a half squared plus 4. A half to the 4th is going to be 1 half times a half times a half times a half, so that's 1/16. This is going to be a half squared is a 4th, so this is going to be 5/4, and then 4. Now, I'm going to try to make these equivalent fractions to make these easy to work with. So this is 20 over 16, and this is 64 over 16. So 64 over 16. And then that would be, what, 65 minus 20. So 45 over 16, or approximately 2 and 13/16, or something like that, okay? So when x is a half, y is about 2 and around here, okay? And if I were to do negative, right, it wouldn't change much, because notice if I change that to negative and this to negative, everything else would be the same. And so it would also be here. So now I can give you a better kind of feeling about the middle. I know, again, I don't know how far down it goes here. I didn't really do a number in there, but at least I know that it does look something like that. And again, I don't know where these go, and if I wanted to be more specific, I would plug that in, okay? But the important part, guys, is end behavior, your zeros, your multiplicity, so your zeros, your multiplicity, your y-intercept, and then a couple additional points to give you an idea. So again, we're going to keep going. We start with the same concept. We're going to do our end behavior first, and we're going to look at our leading number for that, our leading term. We see that the degree is even and A is negative. So what that means is both ends are going to go in the same direction. They're going to go down, okay? Now, when I'm solving for my zeros, I set the whole equation equal to 0. And what I'm going to do is I'm going to pull out my GCF here. I'm going to pull out a negative 2, this is x squared, and that's going to leave me with an x squared here, minus 1. Okay, x squared minus 1. And then I come through and I can factor a little further because I know negative 2x squared, this is x plus 1 and x minus 1. So when I go to solve, I can even sort of expand this out a little bit to show you something. This is really negative 2x times x plus 1 times x minus 1. And so when you see it like that, you recognize that this x here has to equal 0. This one here equals 0. This one here equals negative 1. And this one here equals 1. So I have in these, so these are my 4 zeros, okay? But in this one here, I have a multiplicity of 2, which means I'm going to bounce off of 0. And then these have a multiplicity of 1. Let me write that down, multiplicity of 1. So I'm going to go through negative 1, and I'm going to go through positive 1. Okay? So I have my zeros, my multiplicity, and again, my y-intercept. If I look here, I don't have a number here, so it's like a 0 is going to be 0. So I'm going to be going through the origin. So when I go to graph this, I'm going to look at my zeros. I'm going to go through 0, 0, right? I'm going to go through negative 1, and I'm going to go through positive 1. My y-intercept is my origin, okay? And I know that both ends are going to go down. So I know this is going to go down, and this is going to go down. Now, again, it's the middle behavior, right, that I'm not real sure of what's happening. So remember that they said we should do some intermediate points. And unfortunately, to do some intermediate points, I'm going to have to do something, again, like negative a half. And I'm probably going to have to do an x is positive a half. I wish I didn't always have to do these fractions, but sadly sometimes we have to do that. So I'm going to figure out what the value is when x is a half, okay? So it's going to be negative 2 times a half to the 4th power plus 2 times a half squared. So negative 2, this is 1/16, and this is 2 times 1/4. When I do the math here, it's negative 1/8, and this is 2/4. I can change the fourths to 4/8, and so I know it's 3/8. So when x is a half, y is positive 3/8. So that's not very high at all. That's like there, okay? And then I do the same thing with negative. Now again, in this case, it just happens to be that when I do the negative, because they're two even powers, it's the same answer. So negative a half always gives me 3/8. They don't always do that, but it does here. So my graph is going to go through the negative 1 and positive 1. So I'm going to go through negative 1 to that point. I'm going to come back down to 0, but I'm not going to go through 0. My multiplicity tells me of 2, tells me I'm going to bounce off of 0. So I'm going to bounce off of 0 and go back up. And then I'm going to come back down and go through 1. And so that pretty much shows that middle behavior. So that's where the bounce comes in and the through comes in. And that all comes from multiplicity. A couple more examples. I'm going to do here another equation. Again, I'm going to look at the end behavior first. And I'm going to look at that leading term. Because it's odd, an odd exponent, right, or odd degree, and it's a positive a value, I know that my graph is going to go down on the left and it's going to go up on the right. Okay? Again, these are things you have to memorize. When I'm doing my zeros, I'm going to set the entire equation equal to 0, and I'm going to solve. Okay? So when I look at this one, I recognize, because I know factoring and GCFs and stuff, that I can factor out an x here. So I have x squared minus 12x plus 36, and I know that I can factor this a little more, x minus 6 times x minus 6. My zeros are going to be x equals 0, 6, and 6. Okay, so obviously it's just going to be 0 and 6, okay? But here I have a multiplicity of 2, which means I'm going to bounce. And here I have a multiplicity of 1, which means I'm going to go through that point, okay? And lastly, my y-intercept, and once again, it's always the constant, and since I don't see a constant, I know it's 0, okay? So I'm going to take all this information now and put it on the graph. So again, I'm going to go through my zeros, and my real zeros are my x-intercepts, so 0 and positive 6, okay? My y-intercept is 0, 0, so it's already there. And my end behavior, I know my left side is going to go down and my right side is going to go up. So again, I'm trying to figure out what am I going to do here in the middle. Now, to really be able to do this properly, I need a couple points in the middle. So I'm going to do an x of 2. I'm going to check here, and I'm going to do an x of 4 and see what happens there, okay? So let's do, actually, I'm not, let me do, I think the numbers are going to be too big there. Let me do instead, let me do a little bit closer to the zeros. Let me do 1. I'm going to do 1, x is 1, and x is 5, okay? So when x is 1, it's going to be 1 cubed minus 12 times 1 squared plus 36 times 1. So that's 1, and this is 1. So minus 12 plus 36. So it's minus 11 plus 36, and that's 25. So when x is 1, y is 25. So again, I'll just do something up here and pretend that's 125, okay? And then let's do 5. So 5, I feel like, is going to give me a really big number, but we'll see. So it's going to be 5 cubed minus 12 times 5 squared plus 36 times 5. That's going to be really big. 125. 5 squared is 25. 25 times 12 is 300. And 36 times 5 is 180. Yeah. So let's see. So negative 300 plus 280, 305. So that's actually 5. Okay. So when x is 5, y is 5. So it's closer to here. Okay. And so now I can sort of do my graph. Now my graph is not really pretty. Obviously it'd be better in the computer, or something like that on a calculator. But I know that I'm going to go through 0 up to this point up here. At some point I'm going to drop back down. I'm going to hit that point there. And I'm going to get to 6. Now at 6, I have multiplicity, so I'm going to bounce. So instead of going through 6, I'm just going to bounce off of it and go back in the same direction. And again, that's a pretty close wave of what it's going to look like. So the additional points will differ for each of you. You're not all going to give me the same additional points, and you don't have to. Just something to kind of give you an idea of how high this peak is or how low something is, okay? So this one here can be really tricky because if you notice, it's not in standard form. The highest exponent is after, not before. So I have to rewrite this, okay? I can write f of x or y, and it's 3x to the 4th minus 4x to the 3rd. So I have to be very careful here. So my leading term that's going to help me determine my end behavior is going to be the 3x to the 4th. Because the degree is even and this is positive, this means both ends are going to go in the same direction and they're going to go up, okay? My zeros, I'm going to set this whole thing equal to 0. 3x to the 4th minus 4x to the 3rd. I'm going to factor out a GCF, and that's going to leave me with 3x minus 4. And again, I'm going to break this up so that you notice that this is 3x is out here, and then a 3x minus 4. Each one of these gets sets equal to 0, so my zeros are x equals 0, 0, 0. And then this one is 3x minus 4 is 0, 3x equals 4, x equals 4 thirds. So those are my, technically, 4 zeros, which is what I should have because I have x to the 4th power. But of course, this has a multiplicity of 3. Now, because the multiplicity is odd, I'm going to go through 0. And this has a multiplicity of 1, which means through as well. I only bounce if the multiplicity is even. Last but not least, my y-intercept. And yet again, I don't know why all these problems are the same. It's like having a 0 here. And so I know my y-intercept is 0, 0. So my solutions, again, are 0. That's also my y-intercept. And 4 thirds, which is 1 and 1/3. So it's here. Okay. My end behavior is both ends up. So up and up. And I'm going to use an intermediate value to kind of identify how far down my graph is going to go here. So what I'm going to do is I'm going to choose maybe 1. That's an easy one. So I'll come over here and I'll plug 1 in for x. So 3, 1 to the 4th power minus 4, 1 to the 3rd power. Oops, sorry. Okay, 1 to the 3rd power. Okay, so I've got 3 times 1 minus 4 times 1. So it's 3 minus 4, or negative 1. So when x is 1, y is negative 1. So that's an additional point. So when x is 1, y is negative 1. So I know my graph is going to go through 0. At some point it's going to hit this point, turn around, go through 4 thirds and out. My graph looks something like that. If I really did more intermediate points, you'd see that there's more of a little bit of a bump here. It probably goes down and then up or something. But again, it doesn't have to be that precise. Okay. We have 2 more examples, and then we're going to be done with this. Let's go to the next example here. We've got y equals, well, we already see the equation, but when we're doing our end behavior, we're going to look at our leading term, which is 2x to the 3rd. This means down on the left and up on the right. Opposite directions because of the 3, and down, left, up, right because this is a positive. Okay. Our zeros, again, you're going to set it equal to 0, and you're going to factor out your GCF, which in this case is 2x squared, which is going to leave us with x minus 3. This can be expanded out to xx, x minus 3. So again, when I'm doing my zeros, I notice that it's x equals 0, 0. And if I kind of do the math here, you're going to see that x is also 3. So here I'm going to have a multiplicity of 2, which means I'm going to have a bounce. Here is a multiplicity of 1, which means through. And again, sorry, but all these y-intercepts are 0. So again, I come to my graph. I graph 0, 0. That's my y-intercept and my solution there. I graph 3. I know the left is going to go down. The right is going to go up. It's kind of a curve. And then I have to kind of come up with some middle behavior, right? So I'll plug in 1 and I'll plug in 2. So, you know, when x is 1, I'm going to have 2 times 1 cubed minus 6 times 1 squared. So that's 2 minus 6, so negative 4. So 1, negative 4. And then I'll plug 2 in, and I'm going to get 2 times 2 cubed minus 6 times 2 squared. That's going to be 2 times 8 minus 6 times 4, 16 minus 24, or minus 8. So 2, negative 8. So when x is 1, it's negative 4. 4. When x is 2, it's down here at 2, negative 8, something like that. And I bounce off of 0. So I go up to 0, I bounce, I go through here, I come up, I go to 3, and I go through 3 and up. And it should be a curve, but you get the general idea. The last two examples are given to you in a little bit of a different format. And so the way these are presented to you is they're already factored out. And so what I have you do, because we still need to figure out what the leading term is, what the exponent is. And so we've got to kind of figure that part out. So I kind of tell my students, expand it out so you can kind of visualize it. Whether you do f of x or y, it's going to be -1. It's going to be x minus 3 squared, so that's x minus 3 times x minus 3. It's an x plus 1, and then it's an x plus 1 squared, so it's x plus 1, x plus 1. So now we have all of our factors. And so if I was to multiply all that out, which I do not want you to do, to try to create the actual polynomial that got this all started, your leading term would be, okay, or for the end behavior, your leading term would be this number here, and then it would be x to the sum of all these powers. There's 5 of them, so 1 plus 1 plus 1 is x to the 5th. So that's how I would figure out what that leading term would be, and then based on that leading term, then I can determine my end behavior. So because my degree is odd, right, and my a is negative, I know that my graph is going to go up on the right and down on the left. It's opposite directions. The negative part makes up left, down right. When I'm calculating my zeros, this part's really easy because I basically take all those factors that have an x in them and I set them equal to 0. So I do x minus 3 is 0, so x equals 3. I have that one 2 times. And then I do x plus 1 equals 0, so x equals -1, and that one shows up 3 times. So my 5 zeros are these. Okay, obviously on the graph, it only shows up as 2 things, right? It shows up as +3 and -1. Okay, but it is technically 5 solutions, which makes sense because, again, I have an x to the 5th power, which I should have 5 solutions, whether they're all real or all imaginary or a combination. Okay, so now I have my zeros. Okay, so that's what this is, my zeros. So that's my second answer. Here's my end behavior. Here's my zeros. My next thing that we look at, right, is multiplicity. So multiplicity, I have 2 solutions. I have 3, which has a multiplicity of 2, which means I'm going to bounce. And I have -1, which has a multiplicity of 3, which because it's odd means I'm going to go through it. So I know my graph is going to bounce off of 3, and it's going to go through -1. And last but not least, I'm going to try to find my y-intercept so I can kind of have, a better idea of what my graph should look like. Now, whenever I'm looking for the y-intercept, guys, in any problem, I have to set all my x's equal to 0. So I can do that if I want. I can do it here with the one that I kind of drew out, right? Let me kind of draw that one out. I expanded. Or I can do it off of the original if I wanted. But basically, every x is going to get set equal to 0. So 0 minus 3, 0 minus 3, 0 plus 1, 0 plus 1, and 0 plus 1. So -1, this is -3, -3, -1, oh no, +1, sorry. -3, -3, +1, +1, +1, okay? So -3 times -3 is 3. 3 times -3 is -9. -9 times 1, -9 times 1 times 1, it's all -9. So when x is 0, y is -9. That's my y-intercept, okay? So again, I'll just kind of let's just make that -9, and my graph looks like that. So now I'm pretty much ready to try to graph this. So remember that I have my left side goes up, okay? And my right side goes down. And now let's see if it works. I'm going to go, remember that at -1, I'm going to go through it. So I'm going to go through -1, somewhere to the y-intercept. At some point, I'm going to turn back around, come up to 3, and I'm going to bounce off of 3 and turn the corner. So again, it's through -1 and bounce off of 3. And notice that my ends match. If you do this and your ends don't match, either your end behavior is wrong or your bouncing and your solutions of through and bounce, the multiplicity is wrong. So that's how we graph this one. Again, I'm not going to ask you to do these intermediate points just yet. Just give me this rough sketch. So I should see on my graph, I should see the ends, I should see the zeros, and I should see the y-intercept, okay? And our last slide, again, is that expanded form. It's factored form, basically. So again, I'm going to expand it out. I'm going to get -1. I'm going to have x plus 2, x plus 2. And I'm going to have x minus 3 and x minus 3. So my leading term to determine my end behavior is going to be -1 x to the 4th. And so because my degree is even and this is negative, I know it's going to be both ends down. That's one solution I'm looking for here. When I go to do my zeros, again, each factor that has an x in it is going to set equal to 0. So x plus 2 equals 0. So x is -2, and it's going to occur twice. And then x minus 3 is 0. So x is 3, and I'm going to have that one twice. Okay, so in terms of multiplicity, this one has a multiplicity of 2, so it's going to bounce. And this one has a multiplicity of 2 as well, so it's also going to bounce. Last but not least, I want to find my y-intercept, and I'm going to find that by setting my x is equal to 0. So 0 plus 2, 0 plus 2, 0 minus 3, and 0 minus 3. So it's going to be -1 times 2, 2 minus 3, minus 3. So let me just kind of -1, 2 times 2 is 4, and -3 times -3 is 9. So this is going to be -36. So when x is 0, y is -36. So guys, now I have enough points to do what I need to do on this graph. I'm going to find my zeros, which we already determined were -2. These are my real zeros, and 3. My y-intercept is 0, -36. Let's pretend this is -36. Okay, so that's here. And then my ends both go down. So this side's going to go down, this side's going to go down, and let me see now how my end behave, how the middle should look. Remember, I'm going to approach my 0, and I'm going to bounce off of -2. It's going to go down. I don't know how far down. At some point, it's going to turn back up, and I'm going to bounce off of +2 and go back down again. And so it all works out, okay? So I have my ends, my bounce, my y-intercept. Down the road, I'm going to expect your graph to be more precise to the point where I'm going to want you to go into your original equation, and I'm going to want you to plug in -1 for x and get some y value. I'm going to want you to plug +1 in and get a y value, and I'm going to want you to plug 2 in and get a value. And that's going to help us determine where exactly this point lies, where's the y when x is -1 or 1 or 2. And that'll give us a better view of what our graph should look like. This is just a generic wave, which is not super precise, okay? But that's okay for now for this assignment. We're going to get much more precise when we get to section 3-4.